In this lesson, we're going to discuss outliers and the effects outliers have on our data. An outlier is a value that is much less or much greater than the other values in a data set. An outlier may greatly affect the mean of a data set. This may give a misleading impression of the data. That's at the top paragraph on page 12.7. It's not here on the page, so make sure you highlight the definition of an outlier. Again, an outlier is a value that is much less or much greater than the other values in a data set. Make sure you highlight or underline that. That's an important definition. If we look at the problem here, it says the table gives the number of days that the 24 members of the Garfield Middle School volleyball team were absent from school last year. Does the data contain any outliers? Well, the first thing we want to do is set up a display, which is right here. We have a dot plot. And we take the data here, we put it on a dot plot. And if you notice, hopefully you notice something strange about the 16. You notice all the other numbers are here, and the 16 is out here. This is what we would call an outlier. It is much greater than the other numbers in the set. Now, if it was a 9, I would say no, but there's a big gap. You notice if we talked about gaps, there's a big gap here between 8 and 16. So we're going to look and see how much greater it is than the other values. Most of the data values are between 3 and 8. If you notice, the smallest number is 3 and the highest number is 8. The value 16 is much greater than the rest, so 16 is the outlier. Now if we look at the next example, it says the high temperatures for the week in Foxdale in degrees in Fahrenheit were 43, 43, 45, 42, 26, 43, and 45. The mean of the data is 41 degrees and the median is 43 degrees. Identify the outlier and describe how the mean and median are affected by it. Now again, what we're going to do, we're going to start with drawing a dot plot. And we have 26. Then we have 42. We have 43, 43, 43, 45, and 45. Okay, notice that all the numbers are here except for this one. This is the outlier. So the outlier is 26. Now that we know what it is, we're going to see how it affects the mean and the median. And how to do that, we're going to start by finding the median without it, and then we'll find the mean and median with the outlier and see what happens. So if we take the mean without the outlier, we have 43, 43, 45, 42, 43, 45. We're going to add all those together. We're going to divide by 6. When we add those together, we get 261. And when we divide by 6, we get 43 and a half. And if we want to find the median, again, we have to put them in order from least to greatest. So we have 42, 43, 43, 43, 45, and 45. And to find the median, we have to do the middle. It's an even amount, so we're going to do the middle two numbers, which is here. We add them up, divide by 2, and we're going to end up with 43. So the mean with the outlier was, if we remember, was 41 degrees. And the mean without it is 43 and a half. So it changes it by 2.5 degrees. The outlier made the mean lower. And the median with the outlier is 43, and without it, it was 43, so it didn't affect the median. So if you notice when you do these types of things, you have, if your mean and your median are similar, like they're within 1, then usually there's not an outlier. If you notice it's much different, like this, 41 to 43, then usually there is an outlier affecting it, causing the mean to be pushed one way or the other, depending on where your outlier is. If your outlier is way to the high end, it's gonna it's gonna make the mean higher. And if your mean is lower, like it is in this situation, it's because the outlier is lower, much lower than the rest of the numbers. What I want you to do is answer questions 1, 2, and 3 at the bottom of pages 477, 478 in your small groups.